Next, we will discuss the p-value approach to determine whether a test statistic is too far from its expected value, defined by the null hypothesis. In the p-value approach, too far is defined by the probability of a statistic to be at least as far from the expected value as the current observation. We call such probability the p-value of the test statistic. The region, the area of which is called p-value, is determined by the type of the test, and the value of the test statistic x0, as shown below. Symbolically, the p-value can be expressed in the following way. In the right-tail test, it is the area to the right of the test statistic. In the left-tail test, it is the area to the left of the test statistic. In the two-tail test, it is the area to the left or the right, whichever one is smaller, multiplied by 2. In the p-value approach, the decision whether to reject the null hypothesis or not is made based on the relation between the p-value and alpha. If the p-value of the test statistic is less than alpha, then we consider the test statistic to be a strong evidence against the null hypothesis in favor of the alternative. We just discussed the p-value approach, which utilizes the idea of the p-value of a test statistic. Again, the p-value is a measure of how likely we were to observe such or stronger evidence, assuming that the null hypothesis is true. When the p-value is less than a preset threshold, we consider our observation as strong evidence against the null hypothesis.